3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at Webb's recent progress and upcoming milestones. As per usual, the James Webb Space Telescope has stayed busy over the past few weeks, in preparation for consistent science operations. If you are anything like me, you have kept track of the next generation telescope's progress as it reaches new milestones. Recently NASA gave us a lot of exciting information and future dates to look forward to regarding Webb. This not only included the news about a micrometeoroid impact, but more recently the agency highlighted the schedule of the telescope and what to expect in the future. They also provided a lot of information on how the JWST is expected to reveal elements, molecules, and much more in the coming years. All of which is just around the corner after Webb's over 6-month-long journey in space so far. It took decades of work and billions of dollars, but Webb is set to provide some of its first full-color images, and more in only a few months. This will mark a massive milestone and be the start of something greater. Here I will go more in depth into Webb's recent progress, future schedule, and how it plans to reveal more about this universe, thanks to a recent update from NASA. Webb has made a lot of significant progress in the last few weeks. One of the first important steps had to do with the commissioning of its 17 different modes. Specifically, only a few hours ago NASA tweeted saying, "Keeping up with Webb's progress." Good news, as of today, 7 out of Webb's 17 instrument modes are ready for science. Here, with the telescope optics and instruments aligned, the Webb team is now commissioning the observatory's 4 powerful science instruments. There are 17 different instrument modes to check out on the way to getting ready for the start of science this summer. Once the agency has approved all 17 of these modes, NASA's James Webb Space Telescope will be ready to begin scientific operations. In addition to the continued commissioning of all the modes, the agency also recently shared information on Webb's future schedule and how it will make use of its time most efficiently. After commissioning is finished, NASA says that the fun and discoveries will start. Implementing the hundreds of peer-reviewed science programs that have been selected for Webb's first year. The area on the sky that Webb can see at any given time is called the field of regard. Deciding which observations to make on which day is a complicated process designed to optimize observational efficiency and manage the observatory's resources. NASA asked Christine Chen, Science Policies Group Lead at the Space Telescope Science Institute, to talk about how Webb's schedule comes together. Christine Chen pointed out that Webb will soon transition from commissioning to regular operations, when Webb's time will be devoted to scientific observations. Webb's first year of observations, Cycle 1, has already been selected. There are 3 types of scientific programs planned: General Observer, GO, Guaranteed Time Observer, GTO, and Director's Discretionary Early Release Science, DDERS. The GO and DDERS programs include scientists from all over the world. His programs were selected in a dual anonymous peer review process. During this process, more than 1,000 proposals were submitted by the November 24, 2020 deadline. Scientists hailing from 44 countries applied for a portion of the 6,000 observing hours available in Webb's first year, which represents about 2/3 of all Cycle 1 observing time. The GTO programs are led by scientists who made key contributions to the development of the observatory. All of the observations and approved Cycle 1 programs are available for scheduling at the beginning of regular operations. However, the DDERS observations have been given priority during the first 5 months, because these programs are designed to help the scientific community understand Webb's performance for typical scientific observations as soon as possible. Webb's Long Range Planning Group, LRPG, has created a 12-month-plus observing plan, including all of the approved observations, with the goal of creating the most efficient plan. Even though a Webb observing cycle is defined as a 12-month period, more than 1 year's worth of observations have been approved for Cycle 1. This oversubscription will enable a smooth transition between cycles, as well as provide a repository of flight-ready observations that can be moved earlier if a window opens up. At the current time, before the start of Cycle 1, the observing plan is not yet completely filled. This allows the schedulers to accommodate late-breaking targets of opportunity and directors' discretionary programs. These programs typically include unplanned-for events, such as interstellar comets, gravitational wave sources, and supernovae. During regular operations, the Short-Term Scheduling Group, STSG, will create detailed weekly schedules to be executed by the observatory during the following week. These short-term schedules will take into account several factors, including observing constraints, data volume limits for the onboard data recorder, momentum buildup on the observatory's reaction wheels, etc. At the beginning of each week, the flight operations team will uplink the week's short-term schedule to Webb. At the end of each week, the LRPG will update the observing plan to reflect the actual programs that were executed, and to identify priorities for the following week. In this way, the LRPG and STSG work synergistically together throughout the observing cycle to maximize the scientific return from the observatory. Now that we know more about some of Webb's recent progress, upcoming plans, and an idea of its future schedule, we can take a closer look at some of the telescope's unique features. Recently, NASA asked two of the Mary commissioning team members, David Law, of the Space Telescope Science Institute, STSCI, and Alvaro Labiano, of the CAB, to explain Mary's medium-resolution spectroscopy mode, and what makes it so special. They pointed out that one of Webb's most complex instrument modes is with the Mary Medium Resolution Spectrometer, MRS. The MRS is an integral field spectrograph, which provides spectral and spatial information simultaneously for the entire field of view. The spectrograph provides three-dimensional data cubes, in which every pixel in an image contains a unique spectrum. Such spectrographs are extremely powerful tools to study the composition and kinematics of astronomical objects, as they combine the benefits of both traditional imaging and spectroscopy. The MRS is designed to have a spectral resolving power, observed wavelength divided by the smallest detectable wavelength difference, of about 3000. That is high enough to resolve key atomic and molecular features in a variety of environments. At the highest redshifts, the MRS will be able to study hydrogen emissions from the first galaxies. At lower redshifts, it will probe molecular hydrocarbon features in dusty nearby galaxies, and detect the bright spectral fingerprints of elements such as oxygen, argon, and neon that can tell us about the properties of ionized gas in the interstellar medium. Closer to home, the MRS will produce maps of spectral features due to water ice and simple organic molecules in giant planets in our own solar system, and in planet-forming disks around other stars. In order to cover the wide 5 to 28 micron wavelength range as efficiently as possible, the MRS integral field units are broken up into 12 individual wavelength bands, each of which must be calibrated individually. Over the past few weeks, the Mary team, a large international group of astronomers from the USA and Europe, has been focusing primarily on calibrating the imaging components of the MRS. They want to ensure that all 12 bands are spatially well aligned with each other and with the Mary imager, so that it can be used to place targets accurately into the smaller MRS field of view. They recently released some early test results from this alignment process, illustrating the image quality achieved in each of the 12 bands, using observations of the bright K giant star HD 37122. Once the spatial alignment and image quality of the several bands are well characterized, the Mary team will prioritize calibrating the spectroscopic response of the instrument. Once these basic instrument characteristics are established, it will be possible to calibrate misses, so that it is ready to support the wealth of Cycle 1 science programs, due to start in a few short weeks. By now it has been around half a year since Webb was launched in late 2021. Since this initial milestone, the next generation telescope has made a lot of impressive progress. While very complicated, NASA has kept us updated and is confident in these early results. Webb has been providing the agency. Now it works towards even more ambitious plans. We will have to wait and see how it progresses and the impact it has on the space industry. Thank you very much for watching.